Right now we will try to figure out using this experience from previous video, assembling water level gauge and connected it to this Chinese sensor. Let's start it. As I said in previous videos, we will use the datasheets to build the simplest circuit, and like I said earlier, so I just maybe repeat, so in this case we need to stabilize power supply because it's not really the level, this sensor, it's just change resistance, so depend on the resistance will be the voltage. If the voltage will be fluctuated in a car, voltage fluctuated, readings will be also fluctuated, so we need the stabilized power supply, and we do it on typical application of LM3914, and like usually is only 1, 2, 3, 4, 5 pieces, 5 elements to assemble it together. To tell the truth, the biggest difficult is to calculate the voltage divider for this, because LM it's read the change of the voltage, so we have to deliver the voltage and use the divider, so it will be lower voltage than we can use from car installation. Let's say it is big simplification, but what I need to do, I need to one experiment more just to check if it's not my calculation, I use the voltage divider calculator, yes, works. So is the voltage divider far in, far out, out, in I set for 9 volt, out we have to from 0 to 5, depend on the R2 which will be our sensor. So let's build something on breadboard and check if it works as it should. Let's say we are ready. Very strange. Okay, so right now it should be 0 volt and it's nearly 0 volt. It shows, so this is like 100 millivolts, so it's a 0.1 volt. Okay, and we're going up, and it not works because because I have wrong. I try to powering it from 2.96, so right now I change it to 9 volts. And it on the multimeter should be around 4 something.
So 5. Okay.
Yeah, so we're going down. And right now is why is 0. Should be 1 digit less. It's okay. Right now is, yeah, still is a quarter of the volt. Should be. So let's say this voltage divider works roughly. So what I have here is all elements of power supply, and right now I have to connect the back. I don't like this universal boards. Okay, let's say it's done. Let's test it. Volt connected, not yet. Right now we need multimeter. It's interesting if I do everything okay. If not, I don't know. Maybe I just gave me proper. Okay, right now we have what's going on. Shortage. Okay, right now we have 4 volts. Let's go to the nine. Jesus, what is that? Give him proper. Okay. Standard preset, but this is multi-turn. Jesus. Standard preset, but this is multi-turn. Jesus, man. Adjust. something wrong. Stupid mistake. I just don't like a solder here, so this small resistors from feedback to adjust wasn't connected properly, and for this reason it was oscillated and not adjust the voltage. Right now it works, so we can start. I can start assembling this piece with driver for LED driver. Okay. Okay, so it looks like that. It's not beauty, I don't like it, this system, but it's so simply, so I decide to use this Breadboard. Okie dokie, so time for first check. Of course the power supply itself I tested earlier, so it works. So right now I just check the basic connections. The meter continue. Okay, I just check if it's ground on, because this is for power supply. We have like so ground is here. Okay, ground is here and should be on the pin 2 off. Okay, it's on the pin 2. Okay, so here is a signal, and signal should be on a 5. 2, 3, 4, 5. We have a signal according this schematic. We should also have a 6 to 7. Okay. 2 to 4. Okay. And 2 to 4. Okay, between 2 and yes, 0. 8 to 7. 7. Right. 8 to 7 is a 1.2 kilo, and it's okay. Between this point, in between these two resistors and 2. Whoa, something wrong. And 2. 0. No, it's okay. Have to be different. Okay. 2 and 2. Yeah. 3.9 is according. So it seems so. Looks or works, not works. So we have all connections what we have to. We need. And right now let's second test. This means we connect the power supply sensor and we check if it works well or not with power. Okay, we switch for 20 volt. We switch on power supply. On power supply right now we have just the maximum is at 13.7 volt, so it should be 13.7 here. Something is wrong, probably this meter on power supply, so 13.4. okay, and according our idea on 2 and 3 should be same. 2 and 3, 9. It's okay because not same, because 9 is should set on this power supply, so we're powering with 9. Is okay. So should be also 9 volt on LED power. Yes, LED power is from here. I have to check. Yes, because we will power LED from this area by talking about this line, and according my schematic here should be, if I change no, come on, okay, means works, at least without chip and display. So I can disassemble it and we can solder. It was done earlier, but I'm not happy with this board and this looks, so I make the second one. So let's solder first this. Okay. Like that, so it will be visible. moment of truth, something wrong. We have shorted somewhere. Looks okay. Something is wrong. If I disconnect sensor, is 0. Yeah, 0. And why this blue one? It means it get all the time, it get black one, pin 1, should be okay. It looks like it get power all the time. This blue one, it's shows, so probably the chip oscillate. I added this anti-oscillating capacitor, but maybe it was not enough, because right now when we're going in, and I don't know why we don't get the minimum and maximum, so I have to check what's going on. First, what I wanna check, I check I wanna see it. What's the voltage we have? $49. It should. Okay. So this is maximum, and to tell the truth, how come? I made mistake. Jesus. Checking so many times. Should be opposite direction. Wrong order. I don't know how I check. But it's wrong order. I have to desolder on the bottom and do it again. Oh my god. As you see, it's nothing below, nothing. Quite long, I'm thinking, so maybe this is like a some bugs in soldering or something like that, but it's not about it. After some research, almost long research, I found why it's going on. Is because this sensor is going and suddenly it's a 950 ohm and nothing, zero. So it means these three are in this area, and right now I have to try to recalculate the divider and add something to make a full scale, maybe not full scale, but works better. Okay, so what we have right now, I cut out this resistor and put the bit bigger one on bottom side. It's easier then. And add one resistor, very low resistor, maybe too low, on Okay, so it's too low. Let's find something bigger. Let's keep it on 7 for the time being. Again, it's not what I wanna get. So this is too big. We get the bottom one, but I want a bit more to the top. So right now let's try to go we get 20. Okay, problem is it's hard to calculate because right now it's okay, but remember the wires will be long, some connectors will be, but let's say we can play with it later on. Okie dokie. So how to do it better? Let's say after a long and painful process is work plus minus as it should. As it should work. Unfortunately, this sensor is resistance from 0 to 190 not perfect matching requirements of LM3914. Was big problem to match resistance with sensitivity of this. It works, but it takes me much longer than I expect. In a test I don't check everything to the end, to the edges, and looks better. Later on was big problems. For me it was big. Okay, so right now what we have to do, we have to fit into the
sounds easy.
Okay, so like that. What we need more kind of box, and this 10 ohm resistor will be connected to the line with the water sensor after I fit everything inside the van and check how is the resistance with connectors of full line, because it makes a kind of difference.